Hey guys, so here we are again, another video to watch, but we really went over the main concept yesterday. I just wanted to go over a couple cylinder problems for you guys to have some examples, and then one hexagon problem, hexagonal prism. So we're back in your notes, and this is number 5. This is a cylinder, and it gives us a couple pieces of information. It gives us that the radius is 4, and the height of the cylinder is 12. So the radius is 4, which means we can draw that in right here. And the height of the cylinder, meaning, again, guys, remember, base to base. The base here is a circle. So to the other base, that's the height of the prism. Okay, so the height is 12. Okay? So, we want to get started. Again, same process. What's the name of the shape? The name is a cylinder. Area of the base. Now, we're going to go over an alternative formula for cylinders, but for now, we're going to do the same formula, and you can use the same formula every time, which is kind of my suggestion so that it's one less thing to memorize. But again, guys, our formula for prisms is 2b plus ph. So right now we're looking for the area of the base, which is the area of a circle. Now a circle is pi r squared. Our radius, they gave it to us, is 4. So pi times 4 squared, which we're going to write as 16 pi, and that's the area of my base. So 16 pi goes in that blank spot. Okay, perimeter of base. Now let's talk about the perimeter of a circle. We call the perimeter of a circle the circumference. Okay, so we know that formula too from Unit 11. And that is C equals 2 pi r. Well, the radius is 4, so 2 times pi times 4, which is 8 pi. That's my perimeter. Okay, height of prism, they gave us that. It's 12. Plug it in. Okie dokie, let's see. My lateral area is P times H, which is going to be 8 pi times 12. 12 times 8 is 96, so we have 96 pi as our lateral area. Next, we will do our surface area, which is 2b plus ph. So that's 2 times my base, which is 16 pi, plus pH, which we already know is 96 pi. So 2 times 16, 32 pi, plus 96 pi. Guys, the pi's are like terms, okay? So just combining these is just like combining like terms, right? So 32 plus 96 is 128, and then we still have our pi. Okay, and the units for this, centimeters. So centimeters squared. There's our answer. That's it. Cylinder's the same idea, guys. Couple different formulas than we're used to. There's going to be a pi involved, but that's about it. I'm going to do another cylinder problem. A little bit quicker. Let's go. Here we are. Gives us a diameter of 12. Okay, so our diameter is 12. Guys, if the whole diameter is 12, that means that the radius is going to be just half of that at 6. Okay, and then it gives me the height of the cylinder, base to base. You need to remember, guys, base to base is 4. All right, let's do it. First things first, name of the shape, cylinder. Area of the base, area of a circle, pi r squared. Pi times 6 squared. 6 squared is 36, so 36 pi. Perimeter of base. Well, the perimeter is my circumference, 2 pi r. So 2 times pi times my radius 6, that's going to be, 2 times 6 is 12 pi. Once you get the hang of this, guys, it ain't no thing. Height of the prism, again, arrow going up, we got 4. And now, plug and chug. My lateral area is perimeter times the height, so that's 12 pi times 4. 48 pi. Surface area is 2b plus ph, so 2. My area of my base is 36 pi plus my lateral area, 48 pi. 2 times 36, 72 pi plus 48 pi. That gives me a grand total. Add them up. 72 and 48 is 120. 120 pi. And inches squared. That's it. So that was number 7 in our notes packet. Now we're going to go on to the hexagon. Okay, now this one's an interesting one, starting with the fact that this is a hexagonal prism. Now we're going to do the same thing, but it gets real interesting when we get to the area of the base. Now I could bring back the 1/2 apothem times perimeter. And we're going to do that when it comes to an octagon or a pentagon or any more of those shapes. But with a hexagon, we realized that there's something special. A hexagon, and a hexagon only, is made up of 6 equilateral triangles. So the area of a hexagon is 6 equilateral triangles. So 6 times the equilateral triangle formula, which is s squared root 3 over 4. Okay, s being the side. The side of the hexagon is 8. So we're going to go 6 times 8 squared root 3 over 4. So 6 times, let's see, 8 squared is 64. 64 root 3 over 4. Okay, I can simplify the 64 over 4. So I still have 6 times 64 over 4 is 16 root 3. And 6 times 16, because I can multiply together these whole numbers, we got 96 root 3. And that's the area of my hexagon. I think this is easier than doing our 1/2 apothem times perimeter. Okay, so again, that's something that's going to take a little bit of practice, but that's the area of a hexagon. Okay, so now moving on, from now on it should be smooth sailing. Okay, the perimeter of my hexagon, we want to go ahead, it should be for hexagons and for these polygons, it's going to be irregular unless noted otherwise. It should be marked for you, but in this case, all of the sides are 8. There's 6 of them, so 6 times 8, 48. All right, guys, height of prism. Be careful here. That's base to base. Remember, we always draw in that arrow base to base, so it's actually 2. And now, we can just plug and chug. So my lateral area, perimeter times height, is 48 times 2. Okay, so we get 96. Now my surface area, that is going to be 2b plus ph. So 2 times 96 root 3, and then plus this other 96. Be really careful here now. Okay, 2 times 96 is 192. I can multiply the whole numbers together. 192, keep the root 3, plus 96. That's it, guys. Do not combine your radical with your whole number. You just want to leave it like this. That is your answer. Let's see if we have units here. Centimeters, so centimeters squared. And that's it. This is going to take some practice, but there's an example for you. Okay, all done. Now your task for the rest of the period is to do the in-class worksheet that you guys have, that Mrs. Jattel will give you. So thank you so much. Good luck.